In this video, we will use Argo CD and GitOps to deploy a simple Kubernetes application. After watching this video, you can install, configure, and use Argo CD and GitOps with any Kubernetes cluster. My name is Ahmed Al-Fakhrani, and this is my channel. Argo CD is an open-source GitOps continuous delivery tool for Kubernetes. It is designed to automate the deployment of applications and infrastructure to a Kubernetes cluster. Argo CD is based on the GitOps methodology. All the configuration and deployment information is stored in Git, and the cluster is automatically synchronized with the desired state defined in Git. Argo CD architecture consists of several components that work together to provide a complete solution for continuous delivery in Kubernetes. We have an API server, a repository server, an application controller, and a Redis server. The Argo CD API server is the central component of the Argo CD architecture. It is responsible for processing API requests from users, interacting with the Kubernetes API server to deploy and manage applications. It is also responsible for monitoring the state of the cluster. The API server is built on top of the Kubernetes API server and uses Kubernetes RBAC for authentication and authorization. The repository server is responsible for managing the Git repositories that contain the configuration and deployment information for the application and infrastructure deployed in the Kubernetes cluster. The repository server interacts with Git to retrieve the configuration and deployment information, and it stores this information in the local cache for faster access. The application controller is responsible for monitoring the Git repositories for changes and updating the Kubernetes cluster to match the desired state defined in Git. The application controller uses Kubernetes controllers to manage the lifecycle of the resources in the cluster, and it monitors the state of the resources to ensure that they remain in sync with the desired state defined in Git. Redis is an open-source in-memory data structure store used by Argo CD to store metadata about the applications and the resources in the cluster. Redis stores information such as the status of application deployments, the state of resources in the cluster, and the history of changes made. By working together, these components provide a complete solution for continuous delivery in Kubernetes based on the GitOps methodology. So now we have a solid idea about Argo CD. Let's see how we can use it. The first thing we need to do is install a Kubernetes cluster. Kubernetes in Docker or KinD is a lightweight, easy option to have a Kubernetes cluster up and running in seconds. You can equally use another Kubernetes cluster solution like Minikube, or if you have a cluster running on some cloud provider or even on-prem, it doesn't matter. As long as you have a Kubernetes cluster, it will work in this lab. In this scenario, we are going to install KinD and enable the Nginx ingress controller so that we don't need to use port forwarding when accessing a running application. To install KinD, we can do the following. First, we need to install Docker. For Ubuntu machines, we need to run the following commands: sudo apt-get update. Then we need to install some prerequisites, so we run sudo apt-get install -y, apt transport https, CA certificates, curl, GNU PG agent, and software properties common. Next, we deploy the GPG key for the Docker repository. Once we have that key, we can add the Docker repository by running sudo apt repository. Then we specify the URL of the Docker repository that we need to add to our list of Ubuntu repositories. Now we need to refresh our repository by running apt-get update. Then we can install Docker and Containerd by running sudo apt-get install -y, docker-ce, docker-ce-cli, and containerd.io. The final step we must perform is enabling the current user to run Docker commands without using sudo. To do this, we run sudo usermod -ag docker, then we specify the environment variable that corresponds to the current user. Next, we run new grp docker to effect the changes without needing to log out and log in back. Now we can ensure that Docker is deployed and can be executed by the current user without using sudo by running docker version. If you are running on Windows or Mac OS, you can install Docker for desktop, which provides an easy-to-use Docker installation without needing to write any commands on the command line. The next prerequisite we need is kubectl or kubectl. This is the tool that interacts with Kubernetes clusters. The easiest way to install the latest version of kubectl is to download the binary file using curl directly. So we run curl and then we paste the URL that can be found in the kubectl documentation. Once the binary file is downloaded, we move it to a location within our path. we can use /usr/local/bin. Following that, we need to set the execute permissions to the file. Now we can check that everything is in order by running kubectl version ---- client. Once we have Docker and kubectl installed, we can install KinD. To do that, we need to get the latest release by going to github.com/kubernetes-sigs/kind/releases. Then we scroll down till we find the downloadable files. As you can see, KinD can be deployed to many different platforms, including Windows, Linux, and macOS. So we copy the appropriate link since we are running Ubuntu on x86-64 architecture. Then we can use a tool like wget in our terminal to download the binary file. Alternatively, we could have downloaded the file in the browser. Once the binary file is downloaded, we need to move it to somewhere within our path. We can use /usr/local/bin for that purpose. Finally, we need to set the execute permissions for this file. Now we can double check that KinD is installed by running KinD version. Creating a Kubernetes cluster using KinD is as simple as running KinD create cluster. This is the simplest way to create a cluster using the latest version of Kubernetes and using the default options. However, we also want to enable ingress for this cluster since we will use it, so we need to create a configuration file that can be used with the cluster first. We can call this file cluster.yaml and paste the following content. This content is copied from the KinD documentation and it is required to be able to deploy the Nginx ingress controller. Now we can create the cluster by running KinD create cluster --config equals cluster.yaml. kubectl has already been configured to access the cluster created for us by KinD. So let's just make sure that we are pointing to the correct namespace, cluster, and context. Alright, now we have our cluster installed and configured. Let's install Argo CD. There is more than one way to install Argo CD to a Kubernetes cluster. In this lab, we are going to use Helm. Helm is considered the package manager of Kubernetes. You can use it to deploy and maintain workloads bundled in deployable units called charts. A chart contains everything a Kubernetes application needs to run. For example, deployments, config maps, services, ingresses, and so on. They can also be customized when or after they are installed to the cluster, as we will see in a few moments. So, let's install Helm. The easiest way to install Helm is to use the script they provide in their official documentation. So we use curl and we paste the URL that is provided and pipe to a script. Now that we have Helm installed, we can deploy Argo CD. Helm uses repositories to store charts. Each vendor may have its repository where it offers its different products. In our case, we need to use the Argo-Helm repository. So we need to add it to the Helm local repositories list by running helm repo add Argo. Then we type the URL of the Argo CD or the Argo project repository. This command adds a new repository from the URL we've supplied and names it Argo so we can refer to it later. Now we are ready to deploy Argo CD. Let's create a namespace first. So kubectl create namespace Argo CD. Then we can proceed with the installation by running helm install Argo CD -n Argo CD Argo/Argo CD. This command installs Argo CD using the chart in the local repository that we've just added and refer to it as Argo/Argo CD. Once the Argo CD resources are created, you can access the Argo CD UI by forwarding the Argo CD server port to your local machine. The Helm output has already provided a command that we can use to port forward connections to the Argo CD server pod. But before doing this, we must determine the initial administrator password the installation created for us. Again, Helm provided us with the command for that. So let's run it. We can start port forwarding by just copying and pasting the command that the Helm chart installation provided for us. Now, this is a virtual machine that I am remotely connected to. So to allow us to link to this instance over the web, we need to add address equals 0.0.0.0, enabling the machine to listen to all interfaces and not just localhost. If you are running on localhost, if you're not using a virtual machine like I'm doing, you can skip this part. Now, once the port forward is active, we can investigate Argo CD by opening the browser and navigating to the machine's IP address where the application is installed, /8080, which is the port where we are forwarding our connections. If you're running this lab on your local machine, you can just type localhost /8080. Once we have the UI, we can enter the administrator credentials. The username is admin, and the password is the one that was generated for us, and we copied it from the terminal. And we are logged in. But notice that to access Argo CD, we had to enable port forwarding and keep the command running for our session. Any other team members who wants to access the server must set up port forwarding first. This adds an extra layer of complexity and could be better. We need to access Argo CD without having to use port forwarding. To do this, we rely on Ingress. Our cluster is already configured to use Ingress. We just need to install the appropriate Ingress controller to enable Ingress to work. There are many Ingress controllers supported by KinD. For this lab, we are using the Nginx Ingress controller. So, we can paste the command provided in the KinD documentation to deploy the Nginx controller that is compatible with KinD. Now we have the Nginx Ingress controller installed. We need to make Argo CD use Ingress. Since we use Helm to deploy Argo CD, we can modify the installation to enable Ingress as follows. Helm upgrade Argo CD --set configs.params. And this is important, between double quotes, server /insecure, then we close the double quote equals true. Notice that it is mandatory to use double quotes here because we are using the / to escape the dot. The reason why we are doing this is that we want to enable a value inside our Helm chart, but this value uses the dot as part of its name. So in order to escape those special characters and not be modified by bash, we need to use the double quotes and the /. This parameter is used so that Argo CD does not attempt to terminate SSL connections and leave that to the Ingress controller. You can either terminate SSL on Argo CD side or on the Ingress controller side. In this scenario, we are offloading it to Ingress. Then --set server.ingress.enabled equals true to enable Ingress, and --set server.ingress.ingress class name equals Nginx to instruct the Ingress object that Argo CD creates to use our Nginx controller as its Ingress controller. Finally, -n Argo CD for the namespace and the Argo/Argo CD for the repository name. In a few seconds, the installation will be reconfigured to use Ingress. Let's get the admin password again. To access the Argo CD server without using port forwarding, we can navigate to the IP address of the virtual machine where it is installed, or if you are doing this on your local machine, you can just type localhost. If you followed all the steps that we had, you should find the Argo CD welcome page available to you on port 80. However, since we are trying to access Argo CD over an SSL connection, we need to accept the risk because obviously Argo CD uses a self-signed certificate and we need to accept this certificate in order to be able to access the page. In more advanced scenarios, you could use a custom SSL certificate from Let's Encrypt or your own CA that your organization provides. But for this lab, we are just using the self-signed certificate. And now we are logged in. So this is how we can access the Argo CD graphical user interface. However, we can manage and control our Argo CD server in other ways. For example, we can do that on the command line interface using the CLI tool. To do this, we first install Argo CD CLI. So let's navigate to the GitHub project where this tool is available. Scroll down till we find the downloadable files and select the appropriate file for our platform and architecture. In the terminal, we can use wget again to download this file locally, move it to a location within our path, and add the necessary execute permissions to the file. Now we have the Argo CD CLI installed. We can use it to log in to the server using the login command argo cd login localhost --insecure. Notice that we are adding the --insecure flag to avoid having to accept the warning that HTTPS certificate could not be validated. Now we need to supply the username, it's admin. The password is the one that we got before, so let's just paste it, and we are logged in. We can control Argo CD from the command line using this method. For example, we can list our repositories by running Argo CD repo list. Of course, we don't have any, but we will add one shortly. A more practical use case, however, is to change the current password. This password was automatically generated for us when we install Argo CD for the first time, so it is wise to change it. We can do that through the command line by running Argo CD account update password -- current password, then paste the current password -- new password, then choose a new password. I've used a password generator to get this, but you can use your own. Next, we need to create a Git repository for our application. We are using GitLab here, but the procedure is essentially the same for other services like GitHub and Bitbucket. So let's log in to GitLab, create a new project. We want a blank one with nothing here. The project name could be Sample Argo CD App. The visibility could be private or public. It doesn't matter since Argo CD will be authenticated to the project anyway. And we don't need a README file. Let's click on Create Project. GitLab already offers the commands to start syncing this repository with our local version. In this scenario, we want to create a new repository from scratch. So we go to the terminal, we create a new directory called sample Argo CD app. And in this lab, we are going to use Kustomize to create our application. So let's create a directory called base. We are going to deploy the Nginx web server. So we will create a deployment.yaml file inside the base directory. The contents of this file could be as follows. Nothing too complex here. It's just a deployment resource. Let's also create a service for this deployment. Then create a file called customization.yaml. This file instructs Kustomize as to which manifests are available in the directory. So you can see we have two manifests. One is called deployment and the other is called service. The namespace that we are deploying the manifests to is the default one. Those files are the base manifests. They won't be touched. To make changes to them, we can create another directory called overlays at the same level as the base one. The overlays directory would not contain any manifests, but only a customization file that dictates what we need to change in the parent manifests in the base directory. So the namespace would still be default, but we need to patch the Nginx deployment. So we use the patches parameter, which accepts a list. The first target that we have is of type deployment. We can refer to the deployment by its name rather than the name of the manifest file, since Kustomize will read all the files in the base directory into memory. Then we specify the type of change we need to do to this deployment. If we want to change, for example, the number of replicas, then we need to specify the entire deployment object till the part of the replicas which lives under the spec parent node. We don't need to add the rest of the deployment object unless other changes need to be made. Now we save the file and commit and push those changes to the remote Git repository. Now our remote repository is in sync with our current one. We need to create an Argo CD application. First, we need to configure Argo CD to connect to GitLab so that it can detect our changes. To do this, we need to create a personal access token. So we click on the profile picture and click on Preferences. From the left-hand navigation, we select Access Tokens. We give a name to our token. Let's call it Argo CD. The token expires, after which it needs to be renewed, which is actually a good security practice. Let's leave it at the default value of 1 month, but you can adjust that to your own preference or your organization's requirements. The access level should be API. Then we click on Create Personal Access Token. Notice that we are only allowed to see the value of this token once. So we copy this value to the clipboard. We need to create a Kubernetes secret to store this personal token so that Argo CD can use it to access GitLab. But for this scenario, we are not using kubectl command line tool to create a secret. Instead, we will use the Argo CD CLI tool to create the secret for us. So we run Argo CD repo add, and we type the repository URL, --username, my username, --, password, then we paste the GitLab token that we have copied before. The above command creates a Kubernetes secret behind the scenes. We can have a look at the object by running kubectl get secrets -n Argo CD. If we look at the output, we can see that we have a secret for our repository. We can retrieve the details of the secret by running kubectl describe secret. Oops, I need to add the namespace, okay. We can see that it contains the username, the password, the type, and the URL of the repository. You can also use the UI to view the repositories. So to do that, we can go to the Argo CD dashboard, go to the settings, then repositories. We can see that we have now our GitLab repository added. If you want to add a repository from the UI, you can do that by using the Connect Repo button, and here you can add the details of your repository. If you are connecting through a token or through an SSH key, you can add all the details here and click Connect. So now we have the repository. Let's see how we can link our sample Nginx application to the cluster using Argo CD. An application in Argo CD is just a set of instructions that makes Argo CD understand how to sync the changes between the repository and the Kubernetes cluster. So we can create an application using the UI or the command line. But since we are learning GitOps here, let's use the declarative way of creating an application. So in our directory, let's create a new subdirectory called Argo CD. This is where Argo CD manifests will live. Inside this directory, we create a new YAML file. We can call it Nginx to reflect that this application is our Nginx installation. The contents of this file are as follows. We start with the API version. This is a custom resource definition, or CRD. So the version is argoproj.io/v1alpha1. The kind is application. In the metadata, the name of this application is Nginx. The namespace must be the same namespace where Argo CD is installed. Otherwise, Argo CD will not pick it up and it will not work. In the spec, we have the project set to default. A project in Argo CD is a collection of applications. We don't have a project in this lab, so we just use the default one. The source of this application is our GitLab repository, so we specify the full URL. Notice that Argo CD can authenticate to this private repository using the secret we created a few moments ago. The path is where our manifests live in the repository. Our manifests are stored in the overlays directory. If you have several environments, for example, because this is how Kustomize is used, you can have, for example, dev, staging, QA, production, pre-production, testing, whatever. So each directory of those could be a customized directory containing a customization.yaml file, and you can have several applications. Each application corresponds to an environment, and each application is pointing to a specific directory within your Git repository. So this is how Argo CD works, and this is how GitOps works in the real world. In this lab, we just use one directory, which is called overlays. It contains our changes to the deployment. Now, the target revision defines the branch or tag we need Argo CD to monitor. We need Argo CD to deploy anything that is in the main branch. However, in other scenarios, you might be using the development branch or maybe the master branch, so you can change the revision here to the branch that you use. Alternatively, you could also add a specific ref. So if you have a branch or a ref, you can just add it here, and Argo CD will refer to this value whenever it wants to pull the changes. The destination defines the cluster Argo CD will use to deploy this application. Since this is the local cluster, we specify the control plane internal URL. But notice here that Argo CD is also capable of connecting to other clusters and managing them from a parent one. So in another scenario or in another setup, you can have Argo CD in a specific cluster. This cluster is called the management cluster, and it is the parent from which other Kubernetes clusters can be managed. So this cluster is connected to the Git repository. It pulls the changes from this repository, and then it applies them to other clusters through this method. So here you define the URL of the target cluster that Argo CD will apply the changes to. In our case, Argo CD is installed within the same cluster that it manages, so it connects to the internal URL of the API server. The namespace here defines which namespace Argo CD will use to deploy the application. We are deploying it to the default namespace. Finally, we have the sync policy. We can let Argo CD sync the changes automatically to the cluster or manually trigger it. Let's use the automatic method. In the automatic method, Argo CD can detect if the cluster has deviated from the manifests stored in the Git repository. The self-heal parameter instructs Argo CD always to keep the cluster in sync with the source. Otherwise, you can just manually apply the changes. In some scenarios, this is needed. For example, you might want to have changes applied to the Git repository, but you don't want them applied automatically to the cluster using Argo CD. Maybe this is a production environment, and maybe you want to have a second look or a third look on the changes before it gets applied, or you want to have the manual apply button under your control so that if something wrong happened, it doesn't cascade to the cluster. So this is why we have this value here. When prune is enabled, Argo CD will delete resources not part of the current Git repository. For example, if we delete the Nginx service manifest and push that change to GitLab, Argo CD will delete the service automatically. Let's set this to true. And let's save the file. And apply it to the cluster using kubectl apply-f nginx.yaml. Now, if we move to the UI, we'll immediately see an application created in the dashboard. The sync status is OK, which means that Argo CD could sync the changes from the repository to the cluster. If we move back to the terminal and check the resources that we have, we see that we have our Nginx pods available. Now, let's test our workflow. Let's say that we want to make a change to the deployment. That change may be decreasing the number of replicas. So we create a new feature branch which decreases the replicas. In this branch, we open the deployment and change the number of replicas. We just decrease them a little bit. And we save the file. And then we can add it to the Git staging area. Following that, we commit the change with a descriptive message. We need to push this branch to GitLab to create a merge request. So we run git push --set upstream origin feature/decrease replicas, which is the name of our branch. Once we do, we have a link that we can visit to create a merge request. So let's do just that. In GitLab, we create a merge request by clicking the appropriate button. In a real-world scenario, another team member or a more senior colleague should review and approve this merge request. Assuming this MR was reviewed and approved, we will merge it into the main branch. Once this happens, Argo CD will detect that the current state of the cluster is different from the desired state stored in Git. So in the cluster we have 4 replicas, but in Git we have 2. So Argo CD now will make what is necessary to reconcile the changes so that the cluster configuration matches what we have in the Git repository. By default, Argo CD syncs with the repository every 3 minutes. If we don't want to wait until this process is done automatically, we can manually trigger it from the UI or the CLI app. Let's use the CLI on the terminal, so we run Argo CD app sync and then specify the app name, which is Nginx. Now we can check the number of replicas in the application by running kubectl get pods. As you can see, the number of replicas is equivalent to what we specified in our Git repository. So, that was all for this video. Thank you for watching.